what are we going to talk about? We're going just to be first talking about Web3 data. Well, why does it even matter? What is it? What can we actually do with it? Why is it different to what we know? What is this actual Web3 thing? Because, well, maybe some of you are not familiar with it. Maybe some of you are familiar. So just by like short show of hands, how many of you think they can define Web3 if they were asked on the street? Okay, we have 2. Nice. That's cool. So we'll do the introduction as well. And then we can see what can we actually do with this thing. Because, well, yeah, as 2 of you may know, there's some things you can do with it. Some of you may not know. So we'll walk you through that. And then we'll actually have the hands-on workshop where we're going to be building an e-commerce app based off all of that. And you just have a laptop. It's just git cloning the GitHub repo. And then you can just work from there. And in the end, we'll just walk through again what we have built. And then we can basically see what can you actually do. Can you build something on top? How would you do that? And, well, who's actually talking to you? Well, it's me. It's Samuel. I was born in 2000 in Hanau, so I may be a little bit on the younger side of code.talks as far as I've seen yesterday. I just developed smart contracts, and on the social platform called Farcaster, smart contracts, as a short introduction, it's just programs that run on the blockchain. So it's just, everyone here is probably somewhat technical, meaning you all know how to code, and I just do the same. It's just not on some mainframe. It's just not in the cloud. It's on blockchain. Whatever that means, we'll get into that. Then I studied computer science at ETH. I'm now moving into my master's, and I come from an application development background, did a little bit of penetration testing for a year in PCI DSS, meaning like banks and credit card industry, which is fun because, as we'll see, smart contracts aren't actually that different from banking software as they're used. And I also did some cloud engineering. So I think that fits quite well. And, well, first of all, why do we even talk about Web3 data? Why do we care? Well, who of you has to work with GDPR? Probably a lot of you. So cookie consent is the easiest way. Everyone knows GDPR. The other ways people know GDPR is, no, we can't do that. It's like typical product meeting is, no, we can't. Why can't we? Well, the data is there, right? No, we're not allowed to use it. It's fun. As a developer, that may not be fun. So usually we have a lawyer with us that tells us, no, we can't do this. And they are just basically there to just make money, right? On the other hand, usually that restricts the user experience because, well, the user expects they can do this thing. The data is there. There's even an API. We just are not allowed to potentially use it depending on the use case we have. Some countries don't even allow the application, so I'm not sure who's familiar with iOS 18.1 and the new AI that Apple has been praising. Well, you're in Germany, you won't get it. Since I'm studying in Switzerland, I get it because I'm not in the EU, meaning I'm not under the European AI Act, which, yay, Switzerland and Germany aren't that different, but still I get an AI feature that Germany doesn't because of EU regulation. Yeah, that's regulation for you. So in a regular area, you typically can't just simply work, and you have a lot of lawyers. So that is why we're talking about Web3 data, because Web3 data actually allows you to use the data. Because, well, you can actually get the data, just not from Web2, as Sidious would say, so you have to join the other side. The fun there is that all of that data is actually public. So if you're working with a blockchain, you may know that Bitcoin is somehow deemed as private. Bitcoin is only private because it doesn't have your ID attached to it. So if you think of going upstairs and just trying to order a coffee, and everyone knows that you order a coffee. They just don't know that it's like Samuel or whoever. So they just know that there is one coffee ordered. So that could also mean that a stock exchange, for example, who's implemented there is sharing order books. I'm not sure how familiar you are with exchanges, but if an exchange shares the order book with another exchange, that exchange can now know what every single customer of theirs wants to do on that exchange. So if you're thinking of, oh, I want to buy 100 Apple shares at $1, and I know that, then I can manipulate the price so that I make money off of knowing that you want to buy Apple at $1. So if I then have enough Apple already and I sell enough, and now I drive the price down or up if I'm just buying, then I may or may not influence your execution and make money off of that. So typically, these exchanges do not share their order books. Well, if we're building on a blockchain where everything is public anyways, then we're actually sharing ordered books by definition. Unless there's some trickery going on and you just don't expose it publicly, but in the end, you will know all the trades that are doing. They could even use the same backend. So you can think of it like, well, typically now you have, in Germany, like Trade Republic, you have your typical Volksbank, Sparkasse. They all have a user interface to buy stocks and transact. Well, if you're on the blockchain, you're using the same backend. So imagine like Volksbank, Sparkasse, all on the same backend infrastructure. Well, this actually works. It's called blockchain. And we have all of that data. So that is quite fun. Also, we can run that software. So you can also run the same backend that then Sparkasse, Volksbank, and all of those exchanges would be using, which is called a blockchain node. It's just a computer running that software. So that's a little more fun than Web 2. Why? Because if you're running that software, you have that data. So nobody can tell you to not use the data because you already have that data. The user, by using that service, already gives you that data. So you have an implicit opt-in from the user without even having them pop up a cookie consent. You still have that on your web page, potentially, but you have their financial history already, right? So generally, before we even go deeper, now you know why we actually have access to that data, but what even is Web3 that we're talking about? Well, in 1959, I wasn't around back then, the internet became known as ISDN and was available in Germany for the first time. The internet by then was actually just already a couple decades old. Why? Because some research institutions already were talking and chatting through the internet, but that was the time when it actually became usable for most people. Still, most people weren't on the internet in 1995. Facebook actually only got 1 million users in 2005. Who knows how many users Facebook has today? 3 billion. So like half of the world is using Facebook. And that's 20 years, right? Like the internet by Facebook having 1 million users was 10 years old already. So the internet itself, like just general internet availability was 10 years old when Facebook got 1 million users. 20 years later, and Facebook basically owns the whole world, and the whole world is on Facebook. Bitcoin itself came out 2 years later. Bitcoin is the most known blockchain, so that's why it's on there. It's also the first really to combine all of this in a way that you can actually run that software and you're part of it. And then a couple of years later, Ethereum came around, and Ethereum is important because we need to know and talk about Ethereum a little bit, because Ethereum is the first platform where you can actually program on it. Well, why can't you program on this like Bitcoin thing? You could build Facebook apps like Farmville, right? Why can't you program on this Bitcoin thing? Well, Bitcoin was just exchanging money, and still is to this day. So if you're like, oh yeah, I just want to send a Bitcoin to code.talks to attend, well, then you can do that. But you actually can't go and say, okay, yeah, I want to, on Bitcoin, verified by Bitcoin, only send 1 Bitcoin to code.talks if they also send me something back. Well, you can't do that. On Ethereum, you could program a smart contract, and that's why I said we'll get to smart contracts. Is what I'm developing, is like you have those rules where you can say, okay, I want you to send me half a Bitcoin, and then I'll send you a full Bitcoin. You could actually guarantee that in a program on Ethereum. You can't on Bitcoin because Bitcoin is not programmable. But it was the first to solve this whole problem of everyone can run that software, and still we all agree that the software has the same data. Well, why is this important? Because Facebook, with 1 million users, is just hosting their own backends. Everyone here is using their own servers. And on Bitcoin, we are all the servers. So just going 2 slides back, this is the same backends, right? And now Facebook has 3 billion users, and we're talking about this thing called Web3. This whole history is basically to show that we went from the internet to Bitcoin to we have programmable money, nice, to oh, we just call it Web3. Why is this important? Because actually Web3 is just terminology. Web3 comes from this like blockchain, crypto, space, whatever. And around 1 year ago, people decided to change the name to Web3 because we go from Web 1, the internet just being static pages, to Web 2, social media, and now to this blockchain thing. Does it make sense? Potentially. Is it just a name change because name changes are fun and you don't associate crypto with tokens anymore? Yes, this is probably the reason that we changed this. So yeah, it's not crypto and blockchains anymore, it's Web3. So just remember that. Whenever you hear Web3, you're not thinking about blockchains, you're not thinking about crypto, you're thinking about Web3, right? So it's still the same technology. Like the tech didn't change, just the name, right? So this is a little important. And generally when one talks about Web3, there's three things that one wants. And one of those things is the community. They want to go direct to consumer. Well, direct to consumer is a Web2 term, actually. Like, direct to consumer is what everyone does on Instagram, Twitter, whatever. Well, you actually don't go direct to consumer because you're going through Facebook and Instagram. You just don't have labels in the music space anymore, not as big. And you actually don't need Rewe to host your product. You can sell it directly on the internet. Well, okay, so you still have that. You still have that community, you want to build that, and that's why like a lot of Web3 folks always say community. When they mean community, they typically talk about customer acquisition. They just call it community. This is one other important thing to know. If you're in that space and you're reading and people say community, usually they mean building a group of followers that eventually they can sell to, which is totally fine, just something to be aware of. And then ownership is typically where the tokens come in. So to just recap, we're not talking about tokens, but ownership and tokens are Web3. So that's fun. And generally we want to be open and collaborate. And the collaboration stems from the tech that is used, right? Like if everyone has the same data, we can use the same data. So every dev in the room can just quickly go spin up their own Bitcoin exchange and have it, because you can look at every other Bitcoin exchange that came before you and you have that code already. And it originates from Bitcoin and Ethereum decentralizing the technology, tokens being used for ownership. So no, we're not talking about tokens. Hey, but we are. And the systems are permissionless. And this is the most important thing. If you go to Volksbank and Sparkasse, they will not let you use their backend. You will have to make deals, you'll have to sign contracts, you have to have lawyers involved, you have to potentially get a banking license or get somebody with a banking license to let you use their tool. You don't here. You can use blockchain from Germany without a banking license. Well, should you? That's a regulatory question. Since I'm not a lawyer, I won't answer that for you. I just can tell you that I have never launched a token because I was advised to not do it. There are legal ways to do it in Germany, but the closest thing to launching a token and having that token be tradable and people expecting to profit off of that token is a stock issuance. So if you want to look into stock issuance terms and regulatory compliance, well, yeah, then that is fun. So one thing people always also say is these apes, I can just right-click and save them, right? Well, the blockchain actually says that you own that ape or not. So if we just agree that this blockchain thing has all of that data and is the same thing that we look at, our shared backend, then it actually matters that it says that we own it. And so yes, you can right-click and save the image, but that doesn't mean that you own it. I can take a picture of a house, doesn't mean I own the house. This is the typical analogy there. So a picture is a picture, but blockchain says I own it is why it's potentially worth $200,000 to some people, not to others. But this is the general gist. Like the blockchain can tell you that you own something and you can use it anywhere because that data is open. And that's where it becomes interesting. So we can actually use all of this to minimize trust. Why? Because this is actually, if you go to Etherscan, this is all the computers making up Ethereum. You can see there's a lot of it in the US. There's also a lot in Germany. And there are also some in China, Australia, and all over the world. So just looking at that, the Sparkasse backend will only be here. It will be this red dot here. This is Sparkasse backend. This is the Ethereum backend. It's a little more. And we still have access to the same data and everything. So if that little monkey that we have here is on that backend, maybe it's a little more fun than being on the Sparkasse backend. That still means, though, that if we only have one guy running all of these nodes, like all of this infrastructure, then it is not decentralized, right? So if you use one single database to store who owns that ape that I showed you, for example, well, then you're just building a Web2 system. So there's not a lot of benefit to building a Web3 system if you can build it in Web2 and it's way easier. Like, it may be a little confusing being at a Web3 hackathon and me saying there's no benefit to it. Well, there's no benefit unless you really need the trust minimization because you're dealing with multiple actors, or you want the proof of provenance, meaning, well, if you send the transaction first, because it's all ordered through this financial transaction ledger, then you actually know that you're the first one to say that, do that, whatever. If I post on social media, well, there could be another post at the same time or similar time, and I don't know if the Facebook backend had an issue, whatever. Because this is just all verified by math, I actually know that I'm the first one. And because we all have that open data and we can join or leave however we want, we also can do this cooperation. And to show you some things that we can do with it, we can move money around. This is something we touched on with Bitcoin a little bit. With Ethereum, we can also program it, which is the sample of I send you 1 Bitcoin, and because you're also sending a half a Bitcoin, I'll just give you the other half back, and now you have 1 Bitcoin, I doubled it, and I still get half back. This is not an interesting example. The more interesting example would be that I work a lot with freelancers, and they're sometimes in India, sometimes in South America, sometimes in Africa, sometimes in the US. And I'm not sure if you have tried sending money to India. You will know that with banks, you're dealing usually with a couple of weeks to get it over there. If you're using like an internet service like Wise, then usually it's a couple of days still. With blockchain, this is 1 second, and it costs me a cent. So no matter how much money I'm sending, I'm paying 1 cent in 1 second, which to me is a lot more convenient than using a bank. So that is why this is my usual use case that I typically do for it. And it's all verified by cryptography, and you can just interact with people without needing to trust them because it's all code. So if you can look into open source libraries, you trust them because it's just their code, you see their code, you know their code. Well, this is the same, it's all public. So what is this Farcaster thing, right? Like Farcaster we actually haven't talked about. We have just talked about a little bit about Web3, and we're going to be building something on Farcaster because Farcaster is social. Well, Farcaster is this thing. It basically looks like Twitter, but you have those buttons here. I'm not sure who knows Facebook's games, but those 2 buttons and generally like a game in a social media thing looks like Facebook Farmville. Well, okay, here it's a little more restrictive. You only have 4 of those buttons at most in an input field. But what we built here is you actually have a Pokemon vending machine. So going all the way back to this programmable money thing, if I can program money, that means that I can know when you send me money, and then I can give you a Pokemon card. And this Pokemon card being a token, and me guaranteeing you as a company that you can claim this Pokemon card, means that you now actually have this. Well, how do you know that only you have this 1 Pokemon card and nobody else just took a picture of it and saved it? Well, this is where it all ties together, and we're using the blockchain as our only source of truth. So if you store an image of that, then it's not the same. And they also have a lot of communities similar to subreddits. You can use those to cluster people into different communities. This will become more interesting later because if you can cluster people into different topics and all of that data you have access to, that means you can do personalization with them having opted in because you have that data already. So the GDPR point just becomes mute, yeah.
That's why I wondered that in your definition, I missed the term identity. So this is really important for
yes.
Identity.
Yeah, so the question is that identity is missing in the Web3 definition. Well, identity in Web3 typically is a blockchain address, right? That blockchain address isn't associated typically with any one of you unless you just deposit funds through a centralized exchange, because there you have your passport attached and then you know who it is. So typically, by looking at the blockchain, I don't know who that is besides the wallet address. So that's why I don't define it as identity. And if you have those social media accounts, then now I know this is Joe, and now I have that identity, and there it's on chain. So yes, there's typically, because you have all the data, you can also associate it with the wallet address. You have identity there. So if you don't really know who it is it really identity, right?
Yeah, I'm referring to different parts of my identity. So if I log into these topics,
Yep.
and I can allow just this part of my identity, my on-chain identity.
Oh, so you're talking about, okay, you can split the parts of identity that you want to know to be public, private.
Do I give to which app?
Well, if all the data is public and associated to your wallet, you give all your data that is public there to the app, because there's no data control.
On-chain, which part of the data?
Well, you can decide what part you put on chain by the apps that you use, yes. Yeah. But otherwise, because all the data we have access to, you can't decide which part of your on-chain data you share. It's like, well, if you're using Facebook and you're using Twitter, then you decided to share some part of that data with Twitter, some part of it with Facebook. If both of those platforms were built in Web3, then both of them would have all those combined data points. So that is something to note. Then there's, and if you have those social media posts, there's a little interaction thing, so you can click actions. And this is really fun as a developer, because if you open the Twitter mobile app, you actually can't interact with the tweet the way you want to. You can, at most, tag a bot, and that bot has to do some command. But you always have to post. It's maybe a little spammy. You don't need to here. So you can build something cool on top of this thing. And you can do that because you have that data. So that's a little more important. Also, Farcaster is spread all over the world, similar to Ethereum, and that's why we're packing them. And coming back to identities on Farcaster are on a blockchain. So they're stored on Optimism. So that way, your Farcaster identity is an on-chain identity. And by how you choose to use it, you expose those parts. You don't expose your Facebook data to Farcaster, or to any on-chain media, that means, unless you decide to post your wallet address on Facebook. And then everyone on Facebook knows, okay, this Facebook username now owns this ape because they posted that they own this ape and they actually include a proof. Well, is a screenshot proof? No. And this is what we talked about earlier. If I go to a home and I take a picture of that home, that isn't ownership. If I show you a piece of paper from the German government saying that I own this house, and you can verify that this is actually true, then I own that house. On blockchain, just giving you a signature of that wallet does that. I'm not sure who's familiar with digital signatures, but it's like I generate a key, and I sign it like in the Middle Ages. You have those little stamps that you can put on your little envelopes. And because that stamp is only known how to be produced for the king, well, you just assume that this is honest by the king. And actually now this is backed up by math. So you don't have to worry about somebody faking your signature. They would have to guess a long, long string that is your key. And there's ways to randomize generating those. Why are we actually talking about this in the social setting? Because Facebook, Twitter, Reddit actually all shut down their APIs. I actually talked to somebody at Facebook who was there early on, who said they had to shut down their APIs simply because, well, the developers were using them a little too much and were extracting data, and Facebook didn't want to deal with compliance on that, meaning we're back to GDPR. Well, here, since everything is open, we actually don't care, because as long as we're one of those dots, we have all the data anyways, right? And for blockchains, that's financial data. For Farcaster, that's social data. Who typically in e-commerce wants to personalize needs financial and social data? Because I need to know, what do you like? Do you like football? Do you like rugby? Do you even not like sports? Do you like chocolate? And then I want to show you this. And then Amazon is one of the greatest at doing that, because they have your data from shopping at Amazon. If you go to Amazon and you log in with a new account, it's just a generic bullshit storefront, because they don't know you. Well, if they were to use all of this data you give them here, they could actually instantly show you a personalized home feed and a personalized storefront. So that's why we're talking about this. So we can actually build an app. And this is where we're going to get practical. So I'm not sure, I'm seeing 1, 2, 4, 5. Okay, I'm seeing 5 laptops. So maybe those without a laptop can team up with people with a laptop, because we're actually going to be building a storefront. Don't worry, you're not going to have to do front-end code. I'm not sure who likes front-end code. Some do, some hate it. So for those that don't like it, you don't have to do any front-end code. I prepared a little basic storefront. And what we're going to do is we're going to use all of that data that we already have, and we can just simply see that we can access it and we can personalize it. And no, please don't get on me for the storefront not being that realistic. We'll simply show different items based on the personalization, right? So here's a GitHub repo that we can use. And I'll just quickly bring up that GitHub so I can show you the task a little more. And this GitHub, you can just quickly clone. And there also are instructions right here on how to run it. If you want to read into it a little more, there's tutorials linked. And you can also obviously ask me questions all the time. This .env you can use right away. No, this is not a secure phrase for authentication. No, this is not secured. You may not want to use this in production. On your local host, this will be fine. And you can just quickly get started with that. I'll quickly bring up the QR code again. And then once you just run it, you will be able to see the storefront. And on the storefront, what's the important part is that you can just change those items. And yes, changing those items is all we're going to do for personalization. So we are going to assume that a person, based on their interest, their social data, is interested in one of those three categories, and we want to just change the category that is shown. So if I just reload that page, then I will just see kitchen. So we want to change it to be bathroom or utility. Most of that code is already there. You just have to implement the adjustment based on the user owning a certain amount of money, the user not owning a certain amount of money. There is a sign up here, and this is going to ask you for a Farcaster account. I'm assuming most of you don't have one, so if you're at the step that you want to test it, let me know. I'll log in with my Farcaster account, and then you have somebody that is logged in. I can just quickly actually demo this. So I'm taking my phone, and I'm scanning that QR code. Then you will see that I will now log in. And up top, at the top right, you're going to see my name, and it's still on kitchen. So we didn't personalize. So we're adding code to change this if I log in away from kitchen. You can choose whatever metrics you want. If you want to make it that, oh, I have posted about bathroom in the last couple of days, which I actually have, then you can see this. And you can do this by simply scanning my posts for the string bathroom. I made it that easy. You can also check whether or not I own a certain amount of Ethereum, like a certain amount of money, and then change it to a different one. And that's just like fun use cases where we can see what we can build if we have access to the data. So let me know once you're at that step so I can log in if you don't have your own account to test. And this is the QR code again. If you're done with that, yes, we also have another challenge that you can do. So for those of you who find cloning a GitHub and changing a couple lines of code too easy, we have another challenge. So for those of you, there's the GitHub. Feel free hacking, and I'll give you around like half an hour, 45 minutes to just crack this. If you have any questions, let me know. I'll walk around and see that you're all set up. So we only have around 20 minutes left. So I'll quickly run through what we have just built and walk us through what we actually did, and then show a little more of what we can do with all of this open data. Based on that, we'll also have time for questions after. We did a little bit of questions already, but we can also go through more as a whole group. Generally, there's also another exercise in the slides, so if you want to try that as well. This exercise is for anyone that wants to build these little apps. So if you want to build something similar to this Pokemon thing, or want to learn how to do that, and actually experience a little more of Farcaster, that is the second exercise. I think most were able to somehow get working with seeing the data, experiencing the data a little bit. So we didn't really need this as like an exercise in the hackathon, but there it is. I'm not calling it homework, but you can take it home. So what did we actually just build? Well, we built a storefront. Well, okay, I provided a storefront. The storefront actually doesn't have a working cart. It doesn't have checkout. It doesn't have most of the things. What we built is we built a personalized single user storefront. Single user is important because, well, typically, if you open Amazon, it's not personalized to you. Only if you purchased a bunch of items and now they know you based off your purchase history. But what we did is we used the amount of money that one person, or like me when I logged in, had. And then we can just take that, and we actually don't need my permission for that. I gave none of you my permission to use that data explicitly. You all were just able to. That may be a little strange, but it's also really, really fun. Because what we were able to build, right? You don't need to ask anyone for permission, and that's the cool thing. So you don't actually have to worry about GDPR in that specific context, right? I'm not a lawyer, so contact your lawyers. But this is what Mark Zuckerberg makes you feel like when you want to develop against Facebook. This is how we felt, because we actually could access that data. And well, I also talked with some of you that are interested in like potentially running that and getting all the data access. Yes, you can run a node, you can feel like Mark Zuckerberg. It may not be America for you, but it may be Web3. And this is basically what we got to. We were able to use the data. Farcaster is social media. So you were able to get my posts. I saw some of you exploring my posts and actually finding the word bathroom in my posts. So you saw that I faked it a little bit because I posted about bathrooms, so you could personalize it for me. We actually had no API in here that can change their terms. Not correct, not fully correct. We actually used an API provider on top of the nodes, so we didn't have to run our own or interact with them directly here. Though you can, if you want to see a sample of doing that, let me know. What can you actually do? Well, you remember that slide. We remembered that, well, Twitter's API now costs us $100 per month as a hobby user. Well, that data that we just used, I think nobody of you paid for that API access and that data. So that is cool. You can develop with it, and you can actually make it so that all of these little apps that were built on Twitter before, on the open Twitter API, could still exist on this text-based network. Well, why? Because we actually have access here. And this is a really overloaded slide of things that could be built with blockchain and then that Farcaster thing, which you can buy Pokemon cards. We saw social media today. You can send money around. Well, we didn't send money. We used money that I hold to change and personalize. And you can also trade, which there's $2.2 trillion already being traded on Uniswap, which is the largest exchange on Ethereum. And $2.2 trillion isn't nothing. And it hasn't broken. It hasn't been hacked. It actually works, which is quite surprising for something that runs on everybody's laptop. Yes, you can run an Ethereum node on your laptop, and that runs Uniswap, which is one of the largest exchanges. If you want to do that outside of this network, you're basically going to Frankfurt, and you're calling into Börse Frankfurt and looking at their data center. So that's actually really, really cool. We remember that we actually wanted to have no middleman. We wanted to remove all of that rust and just use it. Well, we actually did. I think none of you weren't able to access the data, and none of you were shut off by APIs. Even if you were, you could just switch. Well, in the traditional sense, if Facebook cuts you off, there's no third-party Facebook API that you can switch to. If you know of one, please let me know as well. And what you can build is data analysis, personalization, audience profiling, all of it. So we talked about identity a little earlier, where you said, well, some of that identity is on-chain, some of it isn't. All of that on-chain identity and whatever you can actually get, and you could run algorithms against it and see, well, how is the user pattern of that trader? Is it an aggressive trader? Do they trade all the time? If they do, I can identify them, I can market to them, I can reach out to them. Or you can just make sure that if it's an active trader, you exclude them from your platform because you're an artist and you don't want traders and you just want collectors for whatever reason. I don't know. So there's something that we can do there. And how can this actually make it fun? And this is a really, really fun app example. Some of you may have played Facebook games. Some of you know Candy Crush for sure, which is a mobile app. And we saw that in this Farcaster thing, we have this little window for a link instead of just having to click out. This actually became way more fun. Some of you may know Flappy Birds. I at least played it a bunch in the bus to school. And well, yes, there's actually a mint button here. So you could also just do a little transaction on the blockchain and collect one of those little icons for those of you that are connectors. And that way that developer can make some money. But the most fun is that we can play. But not only play, we're not clicking out to another app. We're not even leaving that like Webcast, Farcaster app. We can play in the feed. So you can see, I just clicked play. I'm now opening this little modal, and it actually has my like profile picture here. Why does it have that? Well, because we just saw that we can use that data. It's actually there. I'm now logged into this little app without actually having to log into that app, which is fun. And now I'm actually playing, and yes, I died instantly. My high score is 29. Please try to beat my high score. Let me know if you did. Shouldn't be that hard. The highest one I actually saw is 52. So it's not that high. And to conclude about Farcaster, what excites me the most is I can build without having any API just shut off. Because I can run my own. Worst case, I'm not paying somebody $10 a month to do it for me. I just do my own. Worst case. Best case, it just works, right? But you don't have to rely on the best case. You can actually do it. So this is the conclusion. This is something fun that we did today. We built an app. We learned a little bit around this open data. And that's it from me. If you have any questions, please, there's a mic. Use no mic, raise your hand, and ask. Thank you. So who has questions? I see no questions. OK, then I'll recap some of the questions that we had during the hackathon, if that's interesting. If you want to leave, feel free. There's lunch. Some of the questions I had were, one, why does this blockchain thing actually work? Well, this blockchain thing works because in the math setting, what we do is all of those computers that we saw on this world map, they run the math, run all of that code, and somehow decide that this is the data we should include? Well, no. For Bitcoin, what happens is you have a bunch of GPU power running, and a bunch of energy being used to solve a challenge. The one who first solves that challenge can raise their hand and be like, yay, please include all of this data in the next thing. Like, add all of this data. Meaning, like, if you want to send money to your friend and you solve this problem first, you can guarantee that in the next batch, your money is actually being transferred. Well, how can this be attacked? There's also, there was a fun question about, well, what if I own all of that energy? Well, yeah, then by just the way it works is you can now always do the next set of data. And if you can do that, well, then this blockchain thing actually doesn't minimize trust anymore, right? Well, but since anyone can do that, other people will then say, well, OK, that just means I need more energy and more energy and more energy. And the more people try to do that and other people leveling up their energy usage, the more secure it gets because it's harder and harder and harder to actually get more energy. And that's how Bitcoin is set up and how proof of work, which is the Googleable term, works. Ethereum is a little different. There they don't use energy, they use money. So on Ethereum, if you have a bunch of money, technically you could be the only one deciding what actually gets done on Ethereum, which sounds stupid at first, but actually is really, really cool in that, well, if you're dishonest, you lose money. Well, so how does this work? OK, say we're in a room and you all depend on me being honest. Well, if I'm here and I'm bullshitting, that isn't valuable to anyone. So I'm putting $100 on the table. If any of the things that I say is false, please take some of that money. Well, if some of you do, then I lose money. So since I want to keep my money, I actually want to be honest. But then I'm also saying, OK, please, if I was honest, put a little tip there. And that's what Ethereum does. Ethereum is saying, well, here's my money. I'll be honest. I'll just follow the rules. And if I did, please give me a little tip. And that's how proof of stake works. So if you want to just have all of that network, you need to buy a lot of Ethereum to get there. meaning at one point you may not be able to acquire enough Ethereum because nobody wants to sell to you, or you're just not being honest and then you lose that money. So they use probabilities and that economic model of, I don't want to lose my money here to secure Ethereum. That way it uses less energy, but it's not physically limited to energy, it's now limited to money. So some like that, some don't. The Bitcoiners always say that, oh, since energy is physically limited, we can't produce unlimited amounts of energy because that goes against laws of physics. Bitcoin is more secure. And Ethereum says, well, yeah, but dude, nobody is going to have that much money to hack Ethereum and to just do that. Whatever side of the coin you're on, this is fun. Another question we had is with Farcaster, why would anyone actually use this that it's outside of this room? It was fun to build on, right? But would you use it? It's like, typically you have Instagram, you have your Twitter, you have your Reddit, you already have your communities where the content is. Well, if you want to build on those apps and you want to build some of those experiences, well, then you actually use it because then it's fun and you just saw how this is actually fun. And if you're one of those Twitter devs that was hit by the Twitter API shutting down, then you also see the value in this network. And as more and more developers do that, maybe users find that interesting, you find something that's fun for users, and then users are going to do it. And you're just going to come to the platform. Another way that can happen is that, well, the Farcaster team actually finds a way for it to be a fun and interesting platform, and then you have more users. And if you have more users and you can build those fun experiences, then you may actually be like, hey, this is fun. Now as a developer, I'm coming, and then you have a cycle, right? So this is the two things that are going on. With blockchain, why would anyone use blockchain? Well, we touched on it a little bit, but for me personally, it's being able to just instantly and cheaply send money around. And anything that can be built on top of it, that is really, really cool, like going straight and collecting tokens and collecting art and all of it. But the main use case of blockchain, what most people use it for, is send money around. If you go to Africa, if you go to South America, they actually, most of them don't have access to banks that give them dollars. Because the government is like, oh, if we give you dollars, you're actually not going to use our hyperinflated currency, so that is bad for us. Please don't use dollars. So they could use blockchain and have dollars there. Because as we saw, it's permissionless. They can just do it. So that's some of the questions we had. Are there any questions left? No. Yeah, then I'll just say thank you, everyone, and enjoy lunch.